You can use ChatGPT in a browser, but a real local Jarvis is a different problem. Not a chatbot tab, a local assistant with a giant brain. The difference is not price. It is not just the GPU. It is a leaky bucket. By the end, you will know the laptop spec that actually decides whether local AI feels instant or stuck. Quick fact before we start. 50 million of the things we are about to talk about could fit on a single grain of sand. Hold that thought. Now this. Your computer is a really fast liar. Every number your RAM holds has to be refreshed before it fades, thousands of times faster than you can blink. The lying is what makes everything else work. By minute 3, you will know exactly why. Here is the gap. Your laptop might have 32 gigabytes of RAM. A serious local assistant running a 70 billion parameter model can need 40 to 140 gigabytes, depending on compression. That is not just a software problem. You cannot patch your way past physical memory. It is a count of capacitors, and capacitors do something annoying. They leak. So what is inside that gigabyte? One transistor and one capacitor make one cell. One cell stores 1 bit. 1 bit is a 0 or a 1. There are roughly 8 billion of these cells in every gigabyte. 16 gigabytes of DRAM means 128 billion capacitors, packed across tiny pieces of silicon. Each one is only nanometers wide. Here is where it gets stupid. The capacitor is a tiny pool of electrons. Charged is a 1, empty is a 0, and that pool leaks. Leave it alone for long enough and the bit fades. So the memory controller keeps doing maintenance. It reads a row, restores the charge, and writes the same value back in, row by row. On familiar DRAM timing, that rhythm is about 128,000 refresh beats every second, forever. Watch this. If we turned off refresh for half a second, every photo on your phone, every word you have ever typed, every model weight ChatGPT loaded would start dissolving into noise. The screen would not blink. It would just go wrong. Your memory is not solid. It is a wave that is being constantly redrawn. You would expect this next part to be hard. It is not. Every byte has a number, like a house has an address. The CPU sends that number down a set of wires called the address bus. The chip lights up the matching row, lights up the matching column, and the bit at that intersection flows back along a second set of wires called the data bus. This dance happens billions of times every second. Every model weight ChatGPT touches goes through it. Now, imagine your robot reboots. Cut the power and every capacitor drains. The brain goes black. So when the robot wakes back up, it has to stream 40 to 140 gigabytes of model weights off the SSD back into memory before it can think a single thought. On a consumer laptop, that can become a painful cold start. On a box built for local AI workloads, like NVIDIA's DGX Spark, with 128 gigabytes of unified memory and a price tag of $4,699, it is still not free. Memory loading is the cold start of every robot in the world. Back to the grain of sand. 50 million capacitors. That is real enough as a scale model for modern 1C class DRAM density. The hard part is no longer only making them smaller. The hard part is feeding them. The CPU can ask for 1 bit fast. Asking for 1 billion bits in a row, the actual shape of running an AI model, is slow. The CPU sits there, waiting, until someone invented a different kind of chip. Next episode, your CPU does one thing, billions of times every second, and in AI workloads, a shocking amount of that time is spent waiting for the memory you just learned about. Floor 2 will show you what it is waiting for, and why a GPU, the chip you thought was the Jarvis bottleneck, was actually invented to fix a problem most people still have not noticed. This is how Jarvis actually works. Floor 2.